Hello, class. I got some questions about this particular calculation from the homework in the concavity section, so I'm going to go over it. Again, remember that your numbers might look a little bit different. You might have a 5 and a 7 instead of a 4 and a 3. I didn't specify the interval. We'll say on 0 to 2 pi, just to give us a specific interval to work with. Okay, so I want to go through and carefully work through the numbers in this question just to make sure that you're comfortable with how this is going to end up working out. So the concavity part, I think, is not really the issue that most people are having. I think it has more to do with inverse trig functions. So what do we need? Well, we need to figure out the second derivative first. So f prime of x here is 4 cosine of x plus 3 sine of x. So f double prime of x is minus 4 sine of x plus 3 cosine of x. Okay, so I want to know when that's 0, so I've got to solve minus 4 sine of x plus 3 cosine of x is equal to 0. So that's going to give me that 3 cosine of x is 4 sine of x, which is going to give me, if I move the 4 over to this side and the cosine over to that side, that 3/4 is the tangent of x. Okay. Now, I suspect that most people got here and then weren't sure what to do because it's not clear where on the unit circle this happens. So I know this happens somewhere on the unit circle, and I know that if I draw the unit circle, the somewhere that this happens is living somewhere in here in the first quadrant. So this being 3/4 is saying the x-coordinate's a little smaller than the y-coordinate, so it's somewhere up here. So there's some angle where the tangent of this angle is 3/4. But it's not one of the things that's on our unit circle handout that we've gotten used to looking at. But we have a way to figure out what this angle is. Namely, we have inverse trig functions. So we can write here that this theta, the one in the picture, it is the inverse tangent of 3/4. Okay. So that is where our first derivative, that's where our second derivative is 0. Now, here's an important thing to remember, which is that the function tangent is actually periodic with period not 2 pi like the other trig functions, which should be all the way around the circle, but it's periodic with period pi. So in fact, actually, we get another time when this tangent takes the value 3/4 in the unit circle, exactly pi way more around, which is just the other side. So here at the angle, which is theta plus pi, we also have that the tangent of theta plus pi, that's also 3/4. Okay, so that means that when it comes time for me to draw out my number line and ask myself, hey, where is the second derivative 0? That is where between 0 and 2 pi is it possible that the function changes concavity? There's two places, which are theta and theta plus pi. Okay. Or if you want, I could write this as the inverse tangent of 3/4 and the inverse tangent of 3/4 plus pi. Okay, now I want to figure out on each of these three subintervals, the one from 0 to inverse tangent of 3/4, the one from inverse tangent of 3/4 to inverse tangent of 3/4 plus pi, and the one from inverse tangent of 3/4 plus pi over to 2 pi, whether the function's concave up or concave down. Okay, so let's look at the middle interval first. So the middle interval here, that corresponds on my unit circle to this piece over here. And so one way I can go about this is, again, remember to pick a test point here somewhere in the middle and say, okay, that's my test point. Well, my test point here is going to be pi, because definitely pi is between that's theta and that's theta plus pi. Okay, again, remember, I'm reading this direction from there to there. So pi, that's that point, is there in between. Okay, so what do I do to figure out whether it's concave up or concave down at pi? Well, I take the second derivative and I evaluate it at pi. And the second derivative at pi, that's going to be minus 4 times the sine of pi plus 3 times the cosine of pi. And the cosine of pi is minus 1. The sine of pi is 0, so this is minus 3. Okay. And so that says that on this interval, the function is concave down. Okay. Then I just have to do the same thing for these other two intervals. And for these other two intervals, actually the point I'm going to pick is going to be just the endpoint of the interval. And the reason I'm getting away with doing this is because these are just arbitrary endpoints. They aren't places where the second derivative is 0. If they were places where the second derivative was 0, well, I'd be out of luck. I'd have to pick something between these 2 points, but I don't have to, because actually at 0, the second derivative is not 0, so it's going to tell me what's happening there. Okay, and so the second derivative at 0 is going to be, if I look at it, minus 4 times sine of 0 plus 3 times cosine of 0. And that is going to be plus 3. That's positive, so my function's concave up there. And in fact, actually, if you plugged in if you plugged in 2 pi to the second derivative, well, remember, all these functions are periodic with period 2 pi, so I'll get exactly the same thing as if I plugged in 0, and so the function will also be concave up over here. And so then my answer will be that it is concave up on the interval 0 to the inverse tangent of 3/4, and also the interval inverse tangent of 3/4 plus pi to 2 pi. And it is concave down on the interval inverse tangent of 3/4 to inverse tangent of 3/4 plus pi. And when you're entering this in WebWork, you can write this as arctangent of 3/4, and it will be happy with you. All right, that's how to do this kind of question. But let me know if you have any more questions. As always, until next time, be well.